Okay, hello everybody. We are going to work today on the last section in chapter 13. This is applications of systems of equations. So in section 7, we talked about how to solve systems of equations. We used substitution, we used elimination, and we used graphing. And then in this section, we're going to talk about some ways that story problems can be adapted to systems of equations. There are some of these that are geometry based and some of them that are not. Systems of equations show up all over the place, and I want to make sure that you're prepared for the different kinds of systems that you could see. We are going to do another unit later on this year that talks even more about systems of equations. So for right now, we'll go through these examples, and then there will be some example problems or problems on your worksheet about them. This first one, ironically, doesn't involve systems of equations. So the book gives you a way to find the area of a triangle using systems, but it's really complicated, and we know a way that we can use a different method to find the area of a triangle given points on the triangle. So that's what we're going to talk about today. So find the area of a triangle with vertex points A, B, and C, and we're given the coordinate points. We know a way to find the area of a triangle if we know the side lengths of the triangle. Do you remember Hero's formula? We're going to use Hero's formula here. But in order to use Hero's formula, we need to know the side lengths of the triangle. So we're going to use the distance formula to find them. So we're going to find side AB, we're going to find side BC, and we're going to find side AC. So the sides in between those two coordinate points. So remember the distance formula? The square root of x2 minus x1, so that's 11 minus 2 squared, plus y2 minus y1, 6 minus 3 squared. The square root of BC is going to be the square root of negative 5 minus 11 squared, plus negative 2 minus 6 squared. And then the square root for AC will be negative 5 minus 2 squared plus negative 2 minus 3 squared. And then we'll figure out all of these distances or all of these lengths of the sides. So here we've got the square root of 9 squared plus 3 squared, or the square root of 81 plus 9, so that's the square root of 90. And for the purposes of today, since we're going to use Hero's formula, I'm going to turn this into a decimal approximation, just because Hero's formula is going to work a little bit more smoothly with decimals. So I'm going to change the square root of 90 into 9.49. For BC, I've got the square root of negative 5 minus 11, so that's negative 16, so that's 256 if we do negative 16 squared. Negative 2 minus 6 is negative 8. Negative 8 squared is 64. So I've got the square root of 256 plus 64. That's the square root of 320. And again, the decimal approximation there is 17.89. And then finally, the square root of negative 5 minus 2. That's negative 7 squared is 49, plus here we've got negative 5 squared, which is 25. So that's the square root of 74 altogether. And as a decimal, that would be 8.60. So we want to take these. I'm going to zoom in a little bit. This is kind of far out. We want to take these, and now that they're the side lengths, we're going to put them into Hero's formula. Remember, Hero's formula is the square root of s times s minus a times s minus b times s minus c. And we remember that to calculate the variable s, we're going to say s is equal to a plus b plus c divided by 2. So let's calculate Hero's formula to find the area of this triangle. So first we've got to find s. So here we'll say s is equal to 9.49 plus 17.89 plus 8.6 over 2, and if you calculate that out, your s value is 17.99. So s is 17.99. We're going to stick that into Hero's formula. So we're going to say that this is the square root of 17.99 times 17.99 minus a, which is 9.49, times 17.99 minus B, which is 17.89, times C, which is 17.99 minus 8.6. All right, and we just have to find out what this is going to simplify to. So we end up with the square root of 17.99 times 8.5 times 0.1 times 9.39. And if we multiply all those together, we get the square root of 143.59, which as a decimal approximation is equal to 11.98. So the area of this triangle is roughly 11.98 square units. The rest of these are going to be examples that use systems of equations. So you might have seen something like this in Algebra 1. We can use a system to find the answer here. So it says the sum of two numbers is 87. Their difference is 19. Find them. When you're making a system of equations from a situation, you always want to look for the two variables. So here where it says the sum of two numbers, I know that that's going to be my two variables. I'm going to call them A and B because there are two numbers. The sum means we're adding them, so one of my equations is going to be A plus B equals 87 because the sum of my two numbers is 87. Their difference, we're subtracting my two numbers now, so I'm going to say A minus B equals 19, so their difference is 19. Once we've got two equations with two variables, we can use either method to solve those equations. We can use substitution or we can use elimination. So these are set up already in a substitution sort of way, or in an elimination sort of way, because we have the A's, then we have the B's, and then we have the equal signs. And we can see that if we were to add these two together, we would cancel out our B value. So let's do that. We're using elimination. We're going to cancel out our B value by adding these together. So we get 2A equals 87 plus 19, so that's 97,106. And then we can divide both sides by 2. And we get A is equal to 53. So our first number is 53. In order to find the second number, we can just plug that into either one of our equations here. So we can say A plus B equals 87. So we'll say that 53 plus B equals 87. And then we'll subtract 53 from both sides. So we get B equals 87 minus 53, which is going to be 34. So our two numbers are 53 and 34. We don't need to put them into a coordinate pair like we usually do when we solve systems of equations because we wouldn't really know what is the A value and what is the first value, the X value, and what is the Y value here. These numbers are sort of interchangeable. Once we find them, we know we're done. Here is a coin problem. Coin problems will show up pretty often. Max has $33 in quarters and dimes, and he has 201 coins. How many coins of each type does he have? So when we see something that has to do with money, usually what you will have is you will have a money equation, so an equation that talks about the value of your money, and an amount equation, an equation that talks about the number of coins that you have or the number of items that you have. So if he has $33 in quarters and dimes, that's talking about the amount of money. So that's going to be our money equation. And that's going to mean that we need to figure out what our quarters, which I'll call X, and our dimes, which we'll call Y, are worth, because we're going to talk about the value of this money. So I know that a quarter is worth 25 cents. So I'm going to say that for every quarter, that's going to be 25 cents of value, 0.25Q. Dimes are worth 10 cents. So for every dime, I'm going to say that that's going to be 0.10, 10 cents per dime. And if I add up 25 cents times the number of quarters I have, plus 10 cents times the number of dimes that I have, I get $33 altogether. So that's one of my equations. The other equation is going to talk about the total amount or the total number of things that I have. We equal 201. We have 201 coins altogether. And for this, I'm strictly talking about the number of quarters plus the number of dimes. So if you'll notice, Q stands for the number of quarters in both of the equations. In the top equation, we're doing the number of quarters times the value of each quarter, because we're talking about the value of our money. And in the bottom equation, we're just talking about the number of quarters. Same thing for dimes. That's why these will work as the system of equations that we have. So let's solve this system. Let's see, maybe I'll use a substitution here just to change things up. So I'm going to need to solve one of my equations for the loneliest variable. And I'm going to use this bottom one. We'll use q plus d equals 201. I'll solve it for q. So I'm going to subtract my dimes. I'm going to subtract d from both sides. So I get q equals 201 minus d. All right, so now I know q. I know a value that I can substitute into the other equation for q. Because here where it says 0.25q, now I can write that as 0.25 times 201 minus d, 201 minus my number of dimes, plus 0.10d, I'm using this dime, equals 33. So I'm substituting that value in. Now I have an equation with only one variable. So now I can just solve this equation and get my final answer. So I'm going to distribute my 0.25. That gives me 50.25 plus, or sorry, not plus, minus 0.25d plus 0.10d equals 33. And then let me combine this all together. So that's going to be, combining like terms, negative 0.15d plus 50.25 equals 33. And then we'll solve. So we'll subtract 50.25 from both sides. And we will get negative 0.15d equals, let's see, negative 17.25. And then we just divide both sides by negative 0.15. And we get d is equal to our 115. So there's the number of dimes that we have. In order to find the number of quarters that we have, we're going to plug this into one of the original equations. Maybe I'll plug it into this equation because it seems like the easiest. So q plus d equals 201, so we can say q plus 115 equals 201. Subtract 115 from both sides, and we get q is equal to 86. So those are our two numbers. We have 115 dimes and 86 quarters. Since it says how many of each type, we should probably make our answer look like that. So we should write 115 dimes and 86 quarters. And then we are done there. All right, go ahead and turn this over when we're ready. We have one more example here. So this one is supplementary and complementary angle systems. We're finally getting back into some geometry and some applications. We did problems like this when we were talking about the first 3 chapters in the first try of this class. We're going to see today how we can use systems of equations to solve them instead of the way that we used to be solving them. So it says find the degree measure of 2 supplementary angles if the first angle is 36 degrees more than 5 times the second. So let's draw a picture. We've got supplementary angles here. So we're going to use a supplementary angle diagram. And we know something about supplementary angles. We know they add up to 180. So if this angle is x, I can call this angle 180 minus x because together they're going to add up to 180. Alternately, I could make an equation about supplementary angles, and that equation, if I call this y, would just be x plus y equals 180. And that's the approach that I'm going to take today, is x plus y equals 180. And then we have to use the other information. If the first angle is 36 degrees more than 5 times the second, so we'll call x the first angle. And if x is equal to 36 degrees more than 5 times the second, I can write that as 5y, 5 times the second, plus 36. So 36 degrees more than that. And these are now the 2 equations that I can use to solve my system of equations. This is already set up in a way that I should be able to, I should be able to substitute because I have a lonely variable. I have x equals. So now anywhere I see the x, I'm going to put 5y plus 36. So 5y plus 36 plus y equals 180. I substituted that value into my equation. And now I'm just going to solve. Super easy. So I've got 6y plus 36 equals 180. subtract 36 from each side, and I get 6y equals 144. Divide both sides by 6, and I get y equals 24. So now I know that one of my angles is 24. To find the other one, I'll just plug it into the equation. Let's see which one I'll use. The x equals, because it's already solved for x. So I say x equals 5 times 24, 5 times y, plus 36. So together that gives me, let's see, x equals 5 times 24 is 120, plus 36. Together, x equals 156. So our two angles are 156 and 24 degrees. We'll put the little degree measures on there, and we are finished. So sort of a shorter section today. It is the end of chapter 8, chapter 13. So go ahead and work on the problems for this one, and then check your answers when you're done. Thank you. Bye.